recording for real. Okay, so what do we want? We want to add chime.xcodeproj
Slash asterisk.
slash
It's a direct.
asterisk.
It's a directory. So
It's a directory, yes. We have samples. We have. Oh, this is what we're gonna ignore, and this is our stuff. Um, we should also hard code this guy. So then the hash that we have on the just file will just work. But I don't remember how to do that. I don't remember how to do that. So let's not do that right now. So untracked files. Oh, this is because Mageta doesn't want the executable to be in the git ignore, so I'm just gonna delete it. Uh,
why does he not want the executable in the git ignore?
because apparently, his Xcode and Emacs on his Mac, they are all stupid, which means that they will like everything that doesn't matter if it's capitalized or not, everything will be just ignored. So including this folder here,
Oh,
which again is just stupid, and I told him that, but it is what it is. So remove Chime Xcode proj folder from uh, GitHub from upstream.
git. That works.
Boom. That should be enough. Good, good, good. Well, this is I already reviewed this one, so I'm just gonna approve it. You can approve as well if you see if it fits.
I probably have to approve because I requested changes, right?
Yes. Yes, 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 yes.
Let's see.
We're deleting this entire
Chime.
folder. Okay, so what did I say earlier? Oh yeah, so now we're gonna review your PRs after merging this one. That's the thing. Let me put this there.
Approve. There you go.
Okay, so now theoretically we should be able to merge, and we can. Actually, Magetta wants to squash, and I think that's okay because we have a bunch. The arithmetic instructions go. Cool. Next up are the PRs about documentation, flow control.
Yeah. I still need to complete the document, but it can be merged as is. I mean, it's helpful to have,
This
and
is does
it's
nothing.
useful. That's because NOP doesn't do anything.
Yeah,
So
yeah, but it is does. I think it should be does nothing, not do nothing.
I wrote the documentation for each instruction as a sequence of steps. So to do nothing, the first step
Oh,
is
okay,
do
okay, okay.
nothing,
Then that,
and
that
that's
makes
it.
a bunch of sense. Okay. Okay, let's read. So PC fetch the value from the memory address in the PC, write it to ICR, increment PC. Fetch the value from the memory address in the PC, write it to SCR. Is this what we are doing?
It is.
Mm. Jump. Fetch the value from the memory address in the PC, write it to PC, set ISR to 0. I don't remember we doing that. Let me check the code. Let me check out. Done. There. Boom.
You do realize you could have just written git pull, right?
prefer being more explicit about things. So where is this? This is here. This is here. So where are we jumping? Actually, doesn't it's not here anymore. It's here. So we want to do something like a jump. So, oops. And then we do like that. Jump.
You're in the wrong
That's
file.
what we want. That's what we want. Okay, so fetch the value from memory address in the PC. Yes. Write it to PC. We're not writing anything to PC, are we? Oh yes, we are.
Well,
So self.registers for key, and then we are reading from memory the value using the value of PC as the previous values of PC as an address. Yes, but we are not
and
setting ISR to 0.
yeah, that's a bug then.
That's a bug. That's a bug. Hmm. Okay, but I thought we fixed that.
We fixed that on the call instruction. Apparently the jump has the same bug.
Did we fix in the call? Oh yes, we did. It is in here. Okay, so let's do the following. Let's do checkout to your branch. Do a pull, instruction set
Uh,
documentation, and do the bug fix there.
we should probably, let me just update the branch first.
Git checkout
And
instruction documentation.org.
okay, apparently the button to update the branch is not there.
Maybe it's some configuration that we need to do.
Hello, Nathan.
Hello.
Nathan is not chilling for some reason.
Git pull origin master. We have
Nathan,
conflicts.
chill.
The heck? Git config. We want to do a pull rebase false, right? I think so.
Uh,
Boom. Tracks. Yes, it worked just fine. Okay, so let's do a git status. Your branch is ahead of by 5 commits. Git push to. Okay, so let's actually push.
Nathan is not chilling. Nathan, chill.
Nathan is not chilling. Yes, Nathan is not chilling. Okay, anyway. Then we're gonna grab this instruction here, go back to jump, and we're gonna edit here. We're gonna edit there. Let's actually do only one commit with all the changes. So let's actually, yes, only one change. Okay, let's go. Next. Oh, all the jumps require this, man.
All of them, yes.
Yeah, so we definitely have a bunch of bugs. So let's read jump 0. Pop the data stack, yes. If popped value is 0, also if the popped value, yes. Also fetch the value from the memory address in the PC. Write it to PC, set ISR to 0. We only set ISR to 0 if the popped value is 0, right?
Yeah.
In that case, this is where we're gonna add. Else, if the popped value is not 0, also increment PC, which is what we are doing. Nice. Jump plus. Uh,
It's the same thing, but we check if it's positive instead of checking if it's zero.
if it's positive, is greater than, that makes sense. ISR. Yes. Okay, call. Fetch the value from the memory address in the PC. Yes. Increment PC. Push PC to the return stack. Okay, I'm gonna change this just for the sake of being one-to-one with the English. So, where is the return?
Um,
Where is the return thing? Where is the return register? Oh, return
That's
stack,
on
sorry. Return stack.
it's already being done on line 161.
I don't think so. We are not incrementing PC. We are incrementing only the value of PC in the return stack. We're not incrementing PC. Should we?
It doesn't matter because we will overwrite PC anyways.
Oh. Push PC to the return stack. Write the fetched value to PC.
The important part is that the increment comes before we push it to the return stack, and we are indeed pushing value of PC plus one, so that's okay.
I have a question. Write the fetched value to PC. When you say fetched value, you mean reading from memory using the value of PC as an address?
Yes, yes.
Okay. Push ISR to the instruction stack. So I'm gonna change this. Set ISR to 0. Yeah, that makes sense. Return. Pop the return stack. Write the pop the return address to PC. Yes. Pop the instruction stack. Write the pop the instruction word to ISR. Yes. Um, we should also check if the zero messages are correct. We are not doing that, and I'm 100% sure they are not correct. Okay, let's fix the error messages after. So next, halt. I don't remember where the heck halt is. We don't have halt.
We should.
Probably it is not. It doesn't have a special thing because it's too simple. It's just 2 lines. Stop execution. Yeah, it's doing some NS logging stuff and then return. Next up, stack manipulation. Push R. Push R. Yes. Pop the data stack. Push the popped value into the return stack. Push a 0 into the instruction stack. Yes. Push pop R. Pop the return stack. Push the popped value into the data stack. Pop the instruction stack. Okay. Memory. Load A plus. Load A. Well, we don't have load A actually. We should
Uh,
change that.
I was focused on writing the instructions we didn't have yet, so that's why we already had load A when I wrote that document.
Okay, but let's check load A plus. Load the value from the memory address in the A register. So load the value from memory address. Yes. Push the loaded value into the data stack. Also yes. Uh, Increment the A register. Yes. Load, no, store A plus. Pop the data stack. That's not what we are doing. Pop the data stack. Write the popped value from to the memory address in the A register. Write the popped value to the memory.
It's in line 270.
Yeah. Oh, 7.0. Oh, yes. Yes, 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 yes. Okay. Increment the A register. Okay. Load R plus. Load the value from the memory address in the top of the return stack. Load the value from the memory address in the top of the return stack. So we first pop it, then we read from memory using that value. Push the loaded value into the data stack and increment the top of the return stack. Yes. Store R plus. Pop the data stack. write the popped value to the memory address in the top of the return stack. So we need the return stack as well. Write the popped value. Yes, yes, yes. Increment the top of the return stack. Yes. Okay. Now we just gotta fix the error messages, and then we can. Then later on we can make another batch of. Or you can do this right now. What do you want, Marin?
I'd rather get into parsing first.
Sure. Okay, so let's fix the error message. So instruction op push A. Stack on the floor, attempting to push value to undefined A register. Yes, because this is the throw of the if. That makes sense. Next. This one. Attempting to read a value undefined PC register. Yes. Same. 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 Mm-hmm. Same. And then everything else doesn't have it. Okay. So I was wrong. Okay, now let's see if this actually. Well, it didn't change. Well, we did change code, so we actually should uh, see if something. Oh, I need the dash dash impure, of course. And then we do just build, and then we do chime 12, which right now is our benchmark. Right now, that's our benchmark, and that's completely fine. Uh, I never remember. How do I? Yes. Okay. So update uh, instruction methods to follow documentation to follow documentation. Push remote origin. Yes, yes, yes. Refresh. Okay, cool. Then we have all the instructions and all of this. This makes sense. Uh, Actually, now that I think about it, do we have nope implemented?
I think we do actually. Not as a method because it just doesn't do anything, right? It should be in the dispatch table though.
So let's go to vm.m. So nop. So there's a bunch of knobs. Oh, but here it is. Here it is. That's cool. Okay, but this is already good enough, I think. So let me approve this. Let me approve this. Plus a few more. I'm gonna remove this missing. There. Okay. Next up. This is still a draft. So are you not confident?
I'm actually missing some instructions that we should cover, but um, for the code that's actually written there, I think it's okay. If you don't mind it not covering all of the instructions, that is.
Okay, so let's do the following. Because this can change, right? Because we're gonna basically define the syntax right now. So let's check out from this branch, which I just noticed. You are actually trying to merge into my thing. I don't think that's gonna work. Let's change that.
Oh, it should have automatically updated the branch. I wonder if it's because it's a draft.
Oh fuck. Okay, so whatever you did, we're gonna have to check out this commit.
Oh, it might be because of the squash.
I think it's because of the
Yeah,
squash, yeah.
it is because of the squash. Now you see why I don't like squashing.
No, it's not because of the squash. It's because we did two branches out of a branch that was not master. I told you this before. If you are
No,
always
that
checking out
actually.
from master, it doesn't matter if you're squashing. But that's not what we did. We did a branch out of master, and then I branch out of that, and then you branch out of mine. And then when I merged mine into Magetas, that was fine. But then when merging Magetas, we squashed. That's why the squashing screwed us.
And now you see why I don't like squashing.
Yeah, no, no, but I already told you this before. If you don't have the policy of checking out of sub branches, squashing will never break you.
But that's the whole point. Like branches are not branches are not special. It shouldn't break you just because the branch you're checking out from isn't master.
No, it matters because if you're not master in the because for instance, what we would have done, like in retrospect, what we could have done, you would merge into mine, and mine would merge into Mageta, and Mageta would merge to master, and then no, nothing bad would happen. But
But if we
because we
did a
didn't care
merge,
about the
but because
order,
but
if you
if we
don't
did a
care, you
merge,
can't squash. That's the thing.
but that's yeah, if we did a merge instead of a squash, then it would have worked. Like the
Yes, yes,
branch
yes.
that
It
I'm
would have
pointing
worked.
to would have changed to master, and it would be fine because like the commits that I'm relying on haven't been squashed away. Like they didn't disappear and magically were replaced by an quote unrelated commit.
No, I agree. If you don't want to care about the order in which you're gonna merge, you can't squash ever. Because squashing is basically rewriting history, basically compressing history. So instead of having multiple commits, you only have a single one. And the reason that some people do that is to have a cleaner history, because you don't want to have useless commits in the middle of your thing.
Define useless.
A commit only adding a new line, a commit only changing some very unimportant name. Multiple things can be considered just pollution for the history. They are not aggregating value for the product. They are just human mistakes, maybe, or dumb mistakes, or experimentation. Uh, and we want to ship what is correct, not an experiment.
But commits are not what we ship. What we actually ship is just the code.
No, of course, we ship the code, but the code was generated by a process, right?
Yes, it was.
So let's make a branch called parsing, and I'm gonna check out this commit. No, I don't want to check out actually. I want to cherry pick. Thank you very much. Okay, so if I do git log, okay, I'm gonna push this already. Nice. Let's make this, and this is gonna be parsing time.
It's morphing time.
Yeah, that's actually a better. It's it's that's gonna be the name of the video. It's parsing time. Okay, add more code samples. So now we need to define what the heck we're gonna parse. So I noticed that you already did that in the samples. What is the simplest one here? This seems to be the simplest one.
So the way I came up with that, it's a line-oriented format where
Okay,
each
actually
line.
before that, can you explain both for the audience and for me how to read this?
Right. So the first line is saying this address in memory that this line represents is called main,
Yes.
and its contents is the instruction sequence literal call halt.
Wait, what is this defining? These four things separated by spaces?
Those are the instructions that are packed in this word in memory.
These are the instructions packed.
Yeah, because remember, we can pack like what is it? 6 instructions per word with
Yeah,
5 bits
no,
per
well, five.
instruction.
We didn't actually we didn't do the upgrade yet. We're gonna do
Yeah, so
that
six.
next parsing after parsing syscalls.
Yeah, so basically each line represents a word, like a machine word. The colon main means this particular address is named main, and then the the characters separated by white space following that are the instructions that fit inside of this particular word. So this word contains the instructions literal, literal, call, halt in that order. And if you don't fill out all of the instruction slots, those are just padded with zeros, which, if you remember,
Oh, okay. So that's we're gonna have to remember that. So these are basically a bunch of PC fetches, right? Or fetches
yeah,
or
zeros
something.
are zeros are PC fetch, which means if we ever reach the end of the instructions that we defined, we just fetch the next word and continue executing from there. In this particular case, that's not going to happen because one of the instructions is halt, but in general, that can happen.
I have some questions.
Sure.
So, if I remember correctly, the literal instruction is the one that you grab the the literal and you put that somewhere. I don't exactly
You put it
remember
on
where.
you put it on the data stack.
Let's
You push
actually
it to
go
the data
to
stack.
VM plus. It's so crazy that we have a plus, a plus with the name of the file. That's okay. I want to see literal. Yes. So what we're gonna do, we're gonna read the value of PC. We're gonna read. We're gonna put the value. Oh, wrong. We're gonna use the PC value as an address. Read that from memory and save that in the data stack. So this is we are basically the memory is everything on here. This is memory.
Yes, yes. This is memory.
Okay. So then, I'm gonna put this just for the sake of completion,
Those
just one.
are those are PC fetches, not nops.
Okay, so fetch, but I'm assuming that's gonna happen
No, no, no.
automatically.
It's PC fetch, not
I
fetch.
understand. No, but that's just
Oh
for
wait.
my sake. That's not. I'm
Oh,
gonna remove this later.
oh yeah. No, but I just recalled that we renamed fetch to literal, so it's fine to have fetch meaning PC fetch. Oh.
Yes, but I think that again that's gonna happen automatically. I don't know how we're gonna do that actually, but it doesn't matter. Then, so when you execute this thing, right? Because again, we are
Yeah.
reading from five to five, right? So actually, it's only one fetch. So
No, it's six. Right now, an instruction is 5 bits, right?
yes.
So it can fit 6 of them in a
Oh, I
32-bit
was doing
word.
the wrong math. Math, sorry. So it's six instructions. It's gonna autocomplete somehow that these two are fetches. That's fine. Then, actually, depending on how we parse it, doesn't really matter because it's gonna be zero anyway. Anyway, uh, so then when you read literal, you're gonna put this into the data stack. Am I right?
Yes, yes,
Then you're gonna read the next one. So you're gonna read these for 13 to the data stack.
yes,
Then you're going to do a call. And if I remember correctly, the call will grab the next thing and jump to that label.
yes. And actually, it's going to jump to that label, but it's also going to push the return stack.
Okay,
It
let's read
would
that.
just Yeah, it would just jump without pushing to the
The
return
PC
stack
is
if it
here,
was a
right?
jump.
At this moment.
The PC is pointing to the equals at this moment. Yes,
Yes, okay. So the value of PC is basically pointing to here. We're going to save that. We're going to put the return stack to here. That's okay. Um, then we're going to use the value of PC as an address to memory. Wait, what are we doing again? We are setting
uh,
to PC oh, we are setting to PC the address in which this label is. So it's probably here.
yes, exactly.
Okay, that makes sense because we're going to execute this now. Then we are putting it into the instruction stack. Uh, we are pushing
the ISR
the
into the
ISR
instruction
into the
set.
instruction
Yeah,
stack. The
because
ISR is
when we
saving this, right?
yeah, because when we return, we don't want to fetch the next instruction. We want to continue executing the instruction we
Yes,
were
yes,
in the
yes, yes. So
middle of.
this is a function call. This is clearly
Yes.
a function call. Is this the easiest example that we have? Like,
I think that's actually just a checklist that's in the old syntax. I think that's the easiest one actually.
no, but this
It's
is
just
still doing a function call. This is also doing a function call. Okay, we don't
I
have
think
an example without a function call. Very marinho this, but okay.
I mean it's a stack language. What are you doing if you're doing a stack machine and you're not doing function calls? Function calls are
Easy,
cheap, man.
easy. Let me teach you. Sum.chf. We're gonna have to discuss the f on that name, but that's okay.
Uh, the only reason I added the F is because Magetta already had
I don't know if we have
page.
add, but then we're gonna
We have tuples
do
actually.
34 and then 35, and then that's it. And then we just
That's
print
it. Don't
the.
forget to halt. Don't forget to
Yes, we
halt.
also need to halt. Yes, and then that's gonna after the data stack, we're just gonna
Right
have 69.
now, yeah, right now our evaluation function, the one that kickstarts the VM, it implicitly prints out the top of the data stack,
Yeah, so
like
this
the
this
top
is the
value.
easiest thing to parse ever then.
Yeah.
Let's finish
Yeah.
this because I'm interested anyway. So then we're gonna jump after the call. Then we are saving a shore, a jump zero, a literal, and a rat. Holy Jesus. Okay, I
Yeah.
actually have no idea what the shore is doing.
It's XOR, man.
So
Exclusive
it's
OR.
so it's basically popping two values out of the data stack and doing a shore with them, XOR, sorry,
Exclusive OR. Yes,
and then putting
bitwise.
that back to the data stack. That's completely fine. Which means that these two numbers have a you chose them on purpose. These are not random.
No, we're testing an equals function, so I chose to put the two numbers there. The value of the number doesn't matter. What matters is that the two numbers are the same.
Yes. Um, okay, then we are doing a jump zero. The jump zero is just gonna detect if the data stack, the top of the data stack has a zero. And if it has, we're gonna do a jump. Um, yes, we're gonna do a jump. If it doesn't have, we're just gonna increment PC. Does the XOR of these two numbers is zero or not?
Uh, it is because
It
it's
is.
exclusive OR, right? 0 and 0 will be 0, 1 and 1 will also be 0. Because those two numbers are the same,
That makes
every
sense. That
every
makes
pair
sense.
of bits will be either 0 0 or 1 1, which means the whole thing will be 0. So yes, it will be.
Okay, then we're gonna jump. So that means
Yeah,
that we're gonna jump to
true.
this thing, and this is
We just
basic. Okay, so this is basically doing another. And then again we are saving the ISR. Well,
uh
we actually are zeroing the ISR, and then we are also just putting PC to point to here.
yes,
That's okay. That's okay. That's okay. Next up, so this is a literal. So this is basically gonna push the -1 into something
into the data stack
into the data stack. Yes. And then we're
and then
doing a
return.
rat. And the rat does.
It's a return.
So we are going to return to what exactly? To the equal?
No, because we came from the equal through a jump, not a call.
That makes sense. We're not saving anything to the return stack when doing jump zero, so we're going to return to here.
Yeah.
So why do we have these things here?
Because if we don't have two equal values, the XOR is going to return something that's not 0, so we're not actually going to jump.
Yes.
So what follows the jump 0 is essentially an else branch.
Oh, okay. So this is okay. So instead of doing a when, we are doing an if then else. Okay.
Yeah, kinda.
Okay. So
Like
then, if we change this to this, for instance, right? We're gonna
Yes.
see the program is still gonna do something.
If we
Uh,
change the numbers to be different, the jump zero is going to fail. It's not going to jump. It's just going to increment the PC. So we skip over the
Wait,
true address.
so if we do the jump zero, at the end of this program, the data stack is going to have -1, and otherwise it's going to have 0.
Yes.
Ah, okay, I see, I see. So I actually want to advertise to parse my program first, before doing the whole call thingy in the jump. But this is definitely
Why?
second in the line, because this is easier. Just for that, this is just easier. And then there's the question, are we going to use this or that?
I mean, whatever you prefer. Like in terms of parsing difficulty, it's just about the same.
No, 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 yeah, that I well, we are using C parsing, right? So I think it's gonna be hell regardless. But my
No, man,
question is,
It's objective C. We we can cheat. We can. Um, how can I say it? We can just do two passes over the text, the program text. One of them to collect the labels, so like colon main, colon whatever. And of course, we can take the opportunity while we're doing that to detect if there's a name collision. And then after that, we just go line by line. Each non-empty line represents a word. So we just pack an integer basically and push it into a mutable
no, no,
array.
no, but we're gonna
And
do that anyway. But I mean, uh, languages like Objective C, I imagine that the parsing is not gonna be like a piece of cake. Like you can't use parser generators like in OCaml, or you can't use parser communicators like
uh,
other
but I'm
stuff.
not suggesting we. I was actually starting from the assumption that we wouldn't do a library. We just write out the parser by hand.
We're gonna do
Like
that. No, but that's where the masochism lives, because it's kind of fun, but at the same time is why, and then we live with this dichotomy forever, and that's fine. The only thing is that I want to discuss the syntax a little bit.
yes.
So why colon here?
Are you asking why the colon character or why it's at the beginning of the line?
Why the colon character?
Because traditionally, in fourth, you use colon to define words.
Okay, so I don't know how forthy our Mageta is gonna allow us our syntax to be, but he's not here, so too bad.
Uh, but that's the thing. Assembly is meant to be a convenient way to represent memory, essentially. Because ultimately, a machine language program is just a memory image, right? That you
Okay, I'm
load
gonna
and
ask why
execute.
the colon in the beginning now.
To make parsing easier, because we only have to look at the first character of the line to have an idea of what the line will be.
Okay, that's true. That's completely true. Okay, so let's start by making a category. Let's start. So parser.h. Actually, that's a lie. It's VM plus parser.h. Pretty cool, pretty cool. Let's go to another buffer. Let's go to VM plus. Yes. So let's see, what do we need? We need that. We're also gonna need this, and then we're gonna have the parser. And then we're gonna have and here. So let's think which things, which things. Actually, let me first ask the question: are we gonna make this a category, or this makes sense to be a completely separate, not related thing to the VM?
It could be completely separate. I don't see why it has to be a category.
No, the only
Like we're
reason.
not
Go.
we're not actually executing anything.
Yeah, no,
We're
the
just
reason my
building.
first instinct was to make a category, because this is the parser for the VM. So this is like in its name has it has some relationship to the VM, but it's not a, like an inner part of the VM. It's almost like a partner.
No, the only thing we depend on is the list of opcodes and how wide each opcode is.
Yeah, no, but that how wide the opcode? What do you mean by how wide the opcode is?
Like how many bits each opcode requires?
Yeah, but the VM doesn't know that, right? Only
It
we do.
should. It very well should, actually.
No, the VM doesn't know how many bits each opcode takes. Only we
Of course
do.
it does. Of course it does. It has to, because otherwise, how it's going to execute the instructions?
No, 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 no. The VM has a function, has a method that packs words into a single 32-bit thingy, right? But that doesn't mean
That's a
that
help.
yeah, but that
No, no,
doesn't mean
that's a
the VM
helper.
knows that each opcode is like 5 bits. It doesn't know that.
It does,
Only we
and
do.
I can actually point you to the exact line of code that has that knowledge. It is let's see, time. Um, I think it's VM. Yes, it's on the chime/vm.m. It's on line 86.
Yeah, but that's exactly what I said. There is a method in the VM that does some math to pack to construct an opcode with all the 5 bits per something something. But if you add, the VM doesn't know this. It only knows that calling this method will do something and return an opcode. But it doesn't know the magic that is happening in here. You know? That's what I mean when I say that the VM doesn't know. There isn't a method saying how many bits per instruction, and then it returns 5. It is in the
They're
middle
very
of the
well.
mess. It's tangled with the implementation. That's what I mean.
We can extract that out, but it doesn't change the fact that this particular method does know how many bits are in an opcode.
I don't want to get into that discussion because for me this is tangled with everything else. Like I said, there isn't a method saying how many bits I have per instruction. This is not known. Uh,
I
from the
think you are
from an outsider perspective, nobody knows that. That's what I mean.
I think you are confusing what the VM exposes in its interface versus what the VM knows internally. And internally, it very much does know that an opcode is 5 bits.
If this was externalized, I would agree. The VM doesn't have any like again, I don't know how to explain this, but for me this 5 is just a 27. It's just implementation details, and by using this method, the VM will never know. But again, that's fine. I'm not gonna be pedantic about that. I just want to ask the question: do we have any benefit of making the parser part of the VM, or is just gonna be something completely separate?
We have no benefit that I can think of,
Let me
like
check here.
whatsoever.
Let me check here. Oh well, what I just said, there is a benefit actually. What I just said, it is a potential benefit. We could make the VM aware. Not the. I'm not gonna use that expression. Not VM being aware. We could provide the VM the capability of informing other other people how many bits per instruction, and then the parser will definitely use that information. Do you agree?
That's fair.
Because for now, we're gonna parse everything with 5 bits. But later, when we add the syscalls, we're going to have to transform that to 6. And I don't want to have two places to remember that, right? So we could
Uh,
just add like a property here, property, and this is definitely retained, which would be bits, bits, to
and
be
as
in integer,
integer.
bits per instruction. And then when we're creating our virtual machine, you need to pass that value actually. So the init uh,
Uh, by the way, quick aside about the syscall thing.
go.
Um, some stack-based virtual machines, they actually take advantage of the fact that we are always interpreting, like, it's a very common thing for forth-based VMs to only have signed integers. They take advantage of the fact that there's no negative memory addresses to say if you try to access a negative address, that's actually a memory mapped IO unit.
I don't know what that means.
So, like, if you, for instance, there's there's a stack-based VM called FreePilter, and the way it does I/O is if you try to read from, for instance, address -1, that actually reads from standard inputs, and if you try to write to -1, it writes to standard outputs
Hmm.
because -1 is an otherwise unused memory address.
Oh, okay. So it utilizes both in and out using the same identifier per se.
That's that's not really the point I'm getting at. The point I'm getting at is that it doesn't actually need dedicated instructions for I/O because I/O devices are mapped to memory addresses.
Oh, okay. I didn't know that. I didn't know that. We could try to make
Yeah,
something similar to that.
that's a thing we can do if we don't want to add a bunch of new opcodes. That's very much an option.
Yeah, that's an option. That's an option. I think for the sake of simplicity, just to get the parsing going, I'm not gonna bother making it scale right now. That's fine. So if we don't need to make an interface, that means that we can just rename this to parser.h. Yes, we can just rename this to parser.h. Then we're gonna have to do the same if def blah 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 like that, and if and this,
Rename opcodes to parser.
yeah, parser parser h. Okay, so what do we need here? Um, we're definitely gonna have to use something like what's the name? There is an utilities.m. There's a function very interesting. Okay, so this we're gonna have to have something like that. Not exactly this one, but I'm just gonna use this as a template. So they're gonna have like parse, and this is gonna receive something like a char star file name, and then this is gonna return a bunch of these.
It should actually return. It should probably return an NS mutable array with that stuff because then we can just pass it to the VM, and that's that as the RAM.
That makes sense. That's a good call. So how the heck do we do that? Because I don't recall at all. Let me check vm.m. Because everything that we do, we just return voids or IDs. I don't remember how to actually return something different. I think it's this ns mutable array. Let's try that. But how do you do it? Do you do it like this? ns mutable array of uint32?
I think it would return an ID actually.
Return an ID to the ns mutable array?
Yes.
Okay, so the first thing that we gotta do is basically this,
Yeah.
that. So let's
And
call
then instead of
this,
program,
yeah, so this is gonna be basically program. Oh fuck. Okay, so what's the name of that?
ID, ID, I guess.
ns mutable array?
I think it should be an ID actually.
Are you sure of that? I really don't think that's the case. You know why? Because this is not an ID. RAM is actually an ns mutable array.
Hmm,
So
okay.
ns mutable array, and I shouldn't be using this. ns mutable array objective C. I always don't remember how to do objective C stuff because, well, of course. Down here, yes. So that's basically what we want. So it's I was close. Where's my parser? Yes. So this is an ns mutable array star called
Pointer.
program.
Yeah.
Called program. Now, another thing that I just remember, we need probably we need something to import probably. So stdlib. That's not what we want at all. So
It's
probably there
foundation,
is.
right?
I
I
think it's
think it's
foundation.
foundation.
Yeah, I think it's foundation as well. So let's add that to this. Cool. Okay, now I think we're gonna have to create a bunch of what's the name tokenizers because this is basically gonna
Ah,
be like a like while we're gonna have to read a file, which again I don't remember. Read file Objective C. Reading from text file. Thank you very much.
wonder, is there something like a bytes array in Objective-C? That would be very helpful.
How to find and read a file on iPhone. Working with files in Objective C. There's a link also that we should take a look, but we're gonna do that later. Oh, so there is a NS file manager.
The the sun burns my eyes.
Yeah, it's very white. Okay, moving, renaming, copying, removing, reading and writing. Okay, so we're gonna use this NS file manager thing. Let's try. So first things first. Okay, so this is an Objective-C abstraction, which is rather interesting. So this is gonna be like, I don't know, program reader.
Oh, it's program source.
Program source, it's okay as well. Source. Then program source, default manager, whatever that means. Then we're gonna do program source, file exit set path. Then we're gonna just put file path, file name. Actually, it's better to use file path. Um, what's up with this equals yes, man? Can I just do this? And then I can
No,
say
no, no.
then
Man, that's a JoJo reference.
what the heck? And there's another thing. It's missing the things. Um,
No, it's not.
and then this is gonna return. So let's return. Well, this is returning ID, so I'm gonna return new. And then we can say something like could not load. Yeah, we should make a function like that actually. So, uh, oh well. Well, later on I'm gonna make abstractions. I'm not gonna bother right now. Yeah. So ns could not load file this, and put file path. Don't remember if this is how it works. Do you remember?
I don't.
Of course not.
Why would I?
Yeah, I think that's how it works. I really do. And then we're not gonna do anything in the else branch. Then
So like, is there a way to dump an entire file into a string?
yeah, that's what we are gonna learn with this tutorial, I think. Okay. Okay, so you can automatically compare them, so it has conveniences, I guess. You can check if it's writable or readable with the permissions thing, probably. I don't really care.
We
We
are
also don't care
renaming.
about that. We also don't care about deletion. We also don't care about symbolic links for now. Reading and writing, that's what we care about. That's what we care about. So
NS data.
contents at path. Uh, contents at path. So that's how you do it. So let's see. So this is going to be a data buffer. I like that name, but I'm going to change it, of course, to program buffer. And I'm going to say that the program source at the content path file path, right? Cool. And what else do I do after that? Having stored the contents in an NS data object, the data may subsequently be written out to a new file using this. But I don't want to do that actually. I really don't want to do that. An NS file handle object can be created when opening a file for reading, writing, or updating. This is achieved using file handle for reading at path, blah blah blah. Having opened a file, it must subsequently be closed when you have finished working with it using the close file method. If an attempt to open a file fails, for example, because an attempt is made to open a non-existing file for reading, this method returns new. For example, the following code opens a file for reading and writing and then closes without actually doing anything to the file. I think that's kind of what we want actually. I really think that's better than whatever file manager. Do you think so?
I'm sorry, I was actually looking at the documentation. What did you say?
Uh, I think we don't need the file manager.
Right.
I think we can just get our stuff working with stuff like this. Open.
Is
Um,
new actually a thing in Objective-C?
yes.
Oh, okay.
Program data. And then am I actually gonna use the same convention that we do in C, putting file in the name? Program file. And then that's it. So we need to do our stuff here. So this is
You
where
need
we parse.
you need to
Where we
rename the
parse.
you need to rename the program source declaration on line 10
Why do I need to rename that? Oh, I do need to rename
because
that.
you renamed it to program file else everywhere else.
There. Okay, so it's basically what we want, right? Do you agree?
Mutable array program. Yes, but I'm looking at the NS data class, and we may actually want to look later on into using an NS data for our program memory instead of mutable array.
Why?
Because apparently it's just a binary mutable binary string that is, which is probably better than an array of references that we're not actually using as references, but only to store numbers.
Okay, so you're saying that instead of using an NS mutable array, we should use an NS data object because
Yeah,
that's
to be
not
more
using
precise,
pointers.
an NS mutable data, because like our memory is just numbers, and the pointers in there are actually just references to addresses in the mutable data itself. They're not actually pointers to real objects, like. Uh, but that's not something we can do right now because we would have to change the VM in order to make that work. So
Okay,
just something to keep in
let's
mind.
okay, so let's actually make a to do. So investigate using NS mutable data instead. Cool. Okay, now it's time. The example that is showing here is kind of what we want. So we need to search for the NS file handle, Objective-C. We need to search for that.
If it
Okay,
has read line, we can just use that.
let's hope. Getting a file handle. No, reading. Read data to end of file and return error. That's kind of a red flag. Returns the available data asynchronously up to the end of the file or maximum number of bytes. So there is a way of reading everything. There is a way of reading everything. What's the return of this? These
Oh, so
returns
so the file handle is not actually. I see.
with notifications. So we can read asynchronously as well. Seeking within a file, operating on a file,
I think we probably
constants.
want to go back to the file manager, probably, maybe,
I really don't want to
possibly.
go back to that.
Why?
because this seems a lot more straightforward. I don't want to surrender just because we can't read by new lines. That's kind of meh.
My first idea is to just dump the entire file into a buffer and
But
parse
that
the
we
entire
can.
thing in memory.
But that we can. It's this.
Okay, that
Uh,
works then.
yeah, that works. So, I have a question. I
Sure.
really do have a question. Right, data to data. Wait, is this writing? Data is an NS mutable data. Then we have the byte string black dog. Then we are putting NS mutable data with bytes, byte string, length of byte string. Then we are opening a file handler. Then we are going to the position 10, writing the data. So we are basically writing black dog and then closing the file. And that makes the okay. So this was probably already there. Yeah, yeah. So this is the content of the thing. Okay, so he pre-made that. Okay, okay. So let's try. Let's try to do. Read it. So let's just make a simple print. So ns log. Okay. Then we're gonna put something like I don't remember how you print any object. I think it's this. I think. You don't
It's
remember that, right?
percent. It's percent at sign.
It's percent like this?
Yeah, but that
Okay.
will print out the type of the object and its address. It's not actually going to print the contents.
Um, are you sure of that?
About 50-50.
Let's try. Let's try this. So let me see what do I need to pass. Reads the available data sequence up to the end of the file or maximum number of bytes. Read data to end of file and return error. Yes, yes, yes. So let's see. I want to see write data. Okay, so the way that the documentation is showing is write data, and the way that the guy is using here is just that. And the write data needs to receive. The write data receives NS data, and this guy
Another
receives
an out
this,
parameter apparently.
an out parameter.
Hmm.
An out parameter. I'm a little bit confused. So this is not a. This is a method. This is a method. I don't think it needs to receive anything because the error here is also showing up, the out thingy.
Yes.
But the guy is not using his example, so we're not going to use that as well. Let's see what happens
Oh,
when try
okay.
to run this. Okay, so let's go to the main.m. We don't actually need any of this. And what we're gonna call? We're gonna call parse.
Ghostbusters.
I didn't get the reference again. I'm sorry. Headers parse dot each. Another thing, I was doing everything here. That's dumb. Parser m. That's where we should do it.
It is.
Let's include headers parser. I believe
And all the
that's
imports and includes that were in there should probably go there as well. Be moves.
where.
Like in parser.h, there's some includes and imports that should probably be in parser.m.
Do you think so? I don't know if I think
stdin
that.
and foundation, I guess.
Let's try without them for now, just for now. Because I think you don't need to do that. Although we are doing that, we shouldn't have to do that if you're already importing this. Let's go to main. So let's try to parse, and I'm gonna provide a file path. Is this how you do that in C? I don't remember at all, man. Samples. Sum. That's it, right? Do you
I
agree?
guess.
I think we can even do better. We
Um,
can even do like that. Yes, something like that. Something like that. Let's see if it compiles. Just build. Headers, that's wrong. Oh, of course, I need to go to the just file. And I need to add a new guy. Because you're using
I knew
C, which means we don't have automatic stuff. So parser. Okay. Unexpected at in program. In program. Do I need to add parentheses?
you need to add an implementation, I think, is the directive. Like,
I really don't think so. I think I
you're
need
not saying that
parentheses.
yeah, you do also.
Oh, something happened? Instance of method read data to end of file and return error not found. Return time defaults to ID. And then it's saying something like receiver is an instance of class declared here. Unused variable. Yeah, that's all good. Does it work? Of course not. So NS invalid argument exception. Reason unrecognized selector sent to instance. Okay, so apparently this read data to end of file and return that doesn't seem to be working for some random reason. Random reason.
We probably want to pass it the actual out parameter for the NS error, right?
But how are we gonna do that?
Well, we have to create a local variable, which and then pass a pointer to that into the method
Yeah, but a local variable of what?
of an NS error because that's what it needs, right?
That
That's what
doesn't
it
make
tries to
sense to
output.
me. Doesn't make sense to me. But let's do what you say. Let's do what you say. Program file. Actually, that's not it. We want return program. I think that's gonna change the. Yes, one of the warnings disappeared. Let's actually try to instead of trying to discover how to make an NS error, let's just search for this. See what happens. Okay, so not a lot.
But we don't actually need to make an NS error. We only have to allocate space for it. And actually only a space to a pointer to an NS error, I think.
Okay, so let's try what you said. So you're saying to make like an NS error,
Pointer.
and this is gonna be what?
Undefined. Just we are not actually going to build one. We're just going to allocate space for it.
Like this,
Yes.
and
And
then pass
then
it here.
I think we need to actually pass the address of error instead of the error itself.
Like this.
That should work, I think.
Nope.
Oh, you need parentheses, of course. It always does.
Also no. I think because this is a pointer, this is already an address. But it's still complaining that read data to end of file and return error is not showing up. I think we need to import something. I really do. But that's what I don't understand. We are already importing a bunch of stuff. Where is the example of the guy? Here. That's what I don't understand. So he is using a seek to file offset. He's using a uh, okay, I have a theory. I do have a theory. Let's create that. Let's put this and say data buffer equals to that, and then print data buffer. It is still mad for some reason.
So try to give the address of error as an argument, like ampersand. Put an ampersand there.
Here?
Ampersand, not an
Oh,
X
here?
sign. I think that might work.
Well,
Not quite.
I don't know if it's gonna work, but yeah, it doesn't work. What are we missing? I don't understand. We are definitely missing some import. Instance method read data to end of file and return error not found. And then it's just saying, yeah, it's just saying you were wrong, my dude. And I understand that. But what I don't understand is read data of length works. And read data from length, read data of length, yes, which is deprecated. Awesome. 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 It is in foundation. Maybe we do need to import foundation twice. Let's try that. No, not found. Return type defaults to ID. That doesn't make sense. That doesn't make sense. That doesn't make sense. Oh, wait, wait, wait. We are dumb. We are just so dumb.
What?
This is data buffer, I believe.
I don't think so.
Read here. You see that the read data of length, then he passes a number.
Yes.
I think this is that number, and then you can pass an error after. But in our case, which is this case here, we... Oh no, but in our case, we only have one thing, which is
I
this.
wonder if the problem is.
You wonder if the problem is...
Let me just check something real quick.
Yeah, definitely not it. I really don't understand. It's saying that this doesn't exist. Read content of file objective C. Here it is. And you can separate them by new line. This is exactly what we want. Okay, so apparently file managers are really bad and file handles are really bad as well for some random reason. See, so I'm gonna just try to understand. So file path. Oh, you're
Oh,
creating
so
an
it
NS string.
oh, so it does read. It does need to pass an address using an ampersand. I was correct.
Oh, you're talking about the error.
Yes.
Yes, apparently yes. Then you're checking if you had an error. Error localized description. It's even really fancy. That Oh fuck. That's not. That's not. Okay, so let's put this. I don't even know if that's gonna work, but that's okay. File path. So why the documentation talks about other stuff? I don't understand. Then you have the contents. Then you can separate by other stuff. Yeah, this is precisely what we want, my friend. Yes. So we can get rid of all of that. So weird. Thank you, Stack Overflow. Unexpected at. So I think you can't do that. So I'm gonna put file name.
No, actually, you are missing the parentheses around the file name.
Oh, you think so? Oops. Okay, so the undo got screwed. Boom, 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 boom. Okay, so let's try to read what we need to read. Can you search what is an NS bundle? We know what is an NS NS string. We know that.
Bundle.
Yeah. Program.
A representation of the codes and resources stored in a bundle directory on disk. Apple uses bundles to represent apps, frameworks, plugins, and many other specific types of content. So it's basically a glorified directory.
Read contents of file. Open. Attempt bad path. Segmentation fault. So I believe we have a problem. I do believe we have a problem. Um, we do have a problem. We do have a problem. Okay, can you log what are you trying to do there? So file path. Can we try to do something about that? Data argument not used by format string. What do you mean? I am using it.
You forgot the percent sign.
Oh, here. Thank you, Marine. Thank you, thank you. No. What do you mean? What do you mean? Am I doing something really, really dumb? Let me try another thing. So what if I do samples, sum? What if I do that? It's also null. So how come? Stack Overflow people, help me. Just help me. Oh, they have even NS search path for directory in domains, man. Oh, and here's a file manager. Oh, you can even. Oh, so it has already JSON serialization. Okay, but let's skip that for now. Let's try to understand this. Um, so what I don't understand is where it's failing. Where is it failing? It is not telling me where. Read contents of file. So I'm calling this somewhere. Okay, let's do the following. Let's change this to NS array. Let's return new and see what happens. Okay. Format specifies type int, but the argument has the type unsigned long. Okay, so it's I think LU. Yes. Okay, it's still bad path, which I don't understand. Do you understand?
I don't.
GF. Maybe I need to do this? Okay, it's worse. Unrecognized selector sent to instance. Invalid argument exception. Okay, so I
You
think you
can't.
can't do, I can't do what I just did there. Yeah, I need this.
Yeah, because like fun fact, the way Objective-C methods work, basically a method is actually a concatenation of each argument's label, like the actual method name as it's recognized while linking. And then the arguments are actually really just positional arguments with the method name spread out between the arguments.
Yeah, I believe you. I totally believe you. Blah 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 blah. We don't need any of this. And I don't understand why this is failing. I don't really understand why this is failing. Do you have any idea why this is failing?
No,
I am very confused. Attempt fail, bad path. File nsdata.m. In bool read contents of file open null. It's trying to open null, which makes sense because the file path apparently is null for some random reason. But I don't understand why. Let's actually try to do a very dumb thing. Let's go and create a my text uh, that. Let's put some hello world and let's try my text and text. Let's try that. It is still completely nuked. So whatever we are missing something very weird. Do you agree?
I agree. It's very sad.
You do agree. Oh, the error changed. Why did the error change? Uncaught exception. NS invalid argument exception. Extended double. Does not recognize localized description. Yeah, the errors are just as bad as like bad standards.
Let's be real here. Did you expect anything different?
Yes, I was expecting error messages a la C, and error messages a la C are not that this bad. They are not this bad at all. The only thing that is still
Oh, you
complaining,
naive summer child.
and the error message changes. That's what I really I don't understand. Oh, it's my list here. Okay, so that's wrong. It should be my text. Okay, it is still exactly the same wrong thing. What are we missing, my friend? Okay, so it's time for us to try something else. Let's try this. And let's try to simplify it as we go there. So this is specifically targeted to JSON, which we don't care. So the first thing it's trying to do is to grab some paths. Then it's grabbing the first one, documents directory. Okay, so this is actually a lot fancier, a lot fancier. A lot very much fancier. Then it's opening a file manager. Then it's checking if a file exists, and it uses that using an ns string. Can we create ns string Objective-C? Can we create one out of like a normal string? Can we do that? Yes, we can. Okay. So let's nuke this, and let's say that we actually want the file path to be there. Yes, that's what we want. We don't need these things. Then we are creating a file manager, then we're doing this, then we're creating an error, then we are reading from that. Then that should be it. Actually, we actually don't care about deserializing it from JSON and stuff like that. We actually really don't care about that. So what we're gonna do is actually this. File contents string with contents of file and blah blah blah. Let's actually print the data, and that's gonna be it. Nslog at dash dash at data, and that's it. What do you think about that? Hmm?
We can try. We can definitely try.
You're not excited, Marinho. You remind me of
I'm
Magueta,
not.
man.
uh, yeah, you need parentheses over there. Oh,
Wait.
something happened.
What
It
happened there?
did it work?
Yes, I think. I think it worked. The problem is that now we need to discover how to handle this NS data thing.
You probably shouldn't have removed the NS error thing that you did.
Oh, the compiler told me to do it
Why?
because we're not using it.
Are you not passing in the address of that variable to something else?
No. No,
Ah,
no, no, no,
okay.
no, 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 no. I have a question.
Yes.
How do we read stuff from NS data? Hmm? Hmm?
NS data is basically a byte string.
Yes, yes, yes. I understand that, but how do we do stuff with it? Like it's not showing me what I want. It's just showing me a bunch of random bytes, and I don't care.
Oh, I think we're very dumb.
Why? Well, that's expected. Why?
I apparently you can initialize an NS data with the contents of a file, and you just have to pass a string with the file path to it. Apparently,
Is that the init that you're talking?
yeah.
Okay, so you're basically saying that we only need these two lines. We can get rid. Well, I don't think we can get rid of we shouldn't get rid of everything, but I'm gonna comment those out. And you're telling me that we can just use init question mark and pass a string to it. Is that what you're talking about?
That's what the documentation leads me to believe. Yes,
Okay, so you're saying init app file. Is that it?
I guess.
I really don't think that's gonna work, but okay.
It didn't apparently.
Okay, so is it init question mark? There isn't examples because why people care? Why I don't understand. With the file specified by path. Yes, that's okay. So is this an S string? Wait, let's. What is this? Oh, this is Swift.
Oh, I see.
Oh. Oh, you can even pass an URL, man. That's cool. It's really cool. NS data init objective C. Aha. String with format. Init with contents of file. Yeah, that's exactly right. That's kind of exactly what we want.
Kinda.
If the data file is somewhere on your hard drive, you must provide full path to your data. Choose encoding if you have saved the file. Oh, it's this, apparently. Let's try. Learning how to do how to do stuff. Learning, 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 learning. So file path, and then we can just get rid of that, and we can get rid of that. Yes, and it's exactly the same thing, but it's shorter, so it's cool. It's kind of cool. But like um I don't like the idea of not having some safety. So something. Okay, so it just returns new. Okay, so here's what we're gonna do. We're gonna put file path here, and data, if data equals new, we're gonna do an ns. Is there an ns error or something? We should search for these things. Probably there is. Could not read file blah. Uh,
Then
what?
yeah, and then file path.
Yes.
Yeah, I don't know. I really don't know. Return null. Return nil.
Yes. Otherwise, we need to discover how to handle this data thing. We need to discover how to handle that. I think we should also put encoding, or that doesn't matter.
If unless the default is something other than UTF-8, doesn't matter.
Okay, so it doesn't matter. So now we need to discover how to separate by new lines. This
No.
NS data was saved to a file. It looks like blah 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 blah. Do you know a way to get this string back as it was in my file.txt? Let's try putting encoding, just to see if the output changes to hello world. Encoding that, and the answer is no. Init with contents of file. Is this? Oh, okay. That's actually wrong. I
That,
misread. I misread that.
that's a
So
different thing, apparently. Yeah.
yes. Uh,
By
so
the
I
way,
think
my internet is oscillating a little bit.
that's okay. Let's put data. Let's put data there. Actually, we should only do this after the if. And then we can print program. Okay, our program now is an NS string. How cool. Yes, go. Okay, this is not correct. Okay, that's it, right? That's precisely it.
That is it, actually.
Okay, so took 1 hour to
To
discover how
figure
to
out how
read.
to read a file.
Yeah, and that's learning for you folks. That's how learning works. Okay, now that we have this, we have a string, right? If we have a string, Objective C, we should have methods to do some sort of like splicing or something.
I wonder if there's a split by lines or something like that.
Split. There isn't a split. Okay, actually, ns string Objective C split. Okay, on the same operator. Yes, there is. Components separated by string, and then you pass the string that you want. Okay, so I don't actually know, but I'm gonna guess it's an array. Uh, so string program, and this is gonna be the program. Actually, this is gonna be the program, and we're gonna do
Hello,
that.
Nathan.
And
Oh, he
Nathan left,
left.
and then he's
And
back.
he's back.
String program, and then this, and then that, and then this. And if I remember correctly, there is a guy, there was a guy showing us how to print. Yes, that's kind of what I want. Then we can do stuff like that. And this is an LU, probably. Yes! Oh yes! It worked! Marinho!
Yes.
It worked, man. It really did.
It, that's great.
That's
That's
great.
great.
That's great. Okay, now we're gonna have to make a function. Fuck. Something on the long on this on the lines of uint 32t, and this is gonna be like a parse. Are we using? Oh, we are using camel case because because yes. So then we're gonna grab one element out of an NS array. So how do I grab one element? So is this gonna be like ID of an element? So
You can.
parsed, and then we're just gonna parse one element and pack into 32 things. Into sorry, into 32 bits.
Um, that's one thing we can do. But actually, we only want to do that if the line doesn't start with either a colon or an ampersand
Wait, so for each individual line, depending on how it starts, you're gonna return something different?
my internet is pretty sad. But yeah, if the line starts with one of those three characters, colon or ampersand,
And I just figured out the thing, man. I just figured out the thing. Do you agree that in our simple program here, when you read the literal, you're gonna push this into the data stack?
yeah, that's what's gonna happen when the program is executed.
Oh, so we're gonna parse into something separate than executing it.
Yeah, we're parsing the
We
assembly
are creating
language.
we are creating memory, right? I need to remember that. We are creating
Yeah,
memory.
we're creating a, like we're reading text and creating a binary program. Like we're building up a memory image of the compiled program.
Uh, okay, so in that particular case, we need to actually have access to the program. Let's make this
Actually,
void for now, and let's put ns array star program. Yes. Then, when reading the line, because now we have lines, right? We can check the first character and check if the first character is column or not, or something like that.
uh, yeah, we probably want to do two passes on the program actually. The first pass, we're actually just going to look at the lines that start with a colon and then like take notes of which line numbers those column lines
So
are.
it's a two-pass parser.
Yes, on the first pass, we just look at the lines that start with a colon and we create what's it called? A hash table,
Yeah,
mutable
NS map table.
NS map table. Yeah, we build up a map table from labels to line numbers essentially.
Okay, so you're saying basically like pass one, and pass one will receive the program, which we just discover how to read into lines, into multiple lines, and it's gonna return the ID is gonna the ID of the map table, if I understood correctly.
Yeah, and in fact, if you want to be a bit safer, instead of returning ID, you can return an NS map table pointer, I guess.
Let's see how we are doing that in the VM. NS map table pointer. Okay, okay. We're gonna have to have some auxiliary functions. So let's make a bool. We don't have bool. So is this how you do boolean? Boolean? I don't remember, man. How do you do booleans?
Oh, that's easy. Zero is false and anything else is
No, no,
true.
no, 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 no. Oh, it's bool with capital. Bool, yes. So is uh is label. Can we do question mark maybe? I don't know if we can do that.
I'm not sure if you.
And we're gonna receive an ID of a line, I believe. And in this function, we have to check if the first character of the line is column. A K A this. And that's pretty much it. So this guy, the pass one, read lines one by one. Um, for each one that is a label line, save that position and label in the map table. Do this while there are still lines to be read. Right? Am I right?
Um, you are correct. And um, if there's a name collision, we have to do something about that. Complain to the user and say, hey, fix your program.
Okay, so this will actually halt if encounter label collision for with some error message. This one, ns mutable array star. So this is going to be pass true. So this is going to have to receive the ns map table labels and the ns array program.
Um,
Then read line one by one. For each one that is a label line, do a lookup in the map table
uh,
to
that's
replace it.
not quite correct. If that's not quite right. If it's a label line at this stage, we actually ignore the label. We only care about the contents of the line. So
But we need to know, we need the address to put in the return stack, no?
we need to know the labels only if we are doing an address reference. So like if the line starts with an ampersand.
Oh, so we need to do that in pass one.
Yeah, in pass one, we build up a map from labels to line numbers, essentially. And then in pass two, for the lines that have a label, we actually ignore the label because we don't care about what the line is called. We only care about what the line actually is.
Yes.
And for lines that refer to labels, which start with an ampersand, then we do a lookup in the map.
Okay, so ignore the label, but use its position when doing when parsing an ampersand with some label. Okay. Actually, this is wrong. So this is it. When parsing an ampersand, do a lookup on the map table with its label and swap it with its position. Uh, okay, so this is actually the place. So change each. How the heck you say this? Mnemonic. Okay, mnemonic with its corresponding opcode and packet
All right, so I got disconnected for a moment, but I'm back.
and pack it into 32-bit words. Uh, Pray you did everything right.
Oh, and one more thing. If the line starts with a hash symbol, we pass the line as an integer, and that's the
Which
value
pass
that
are we
we
doing
put
that?
the second. That's true.
So when parsing a hashtag, we do what?
Parse the line as an integer.
Parse the line as an integer.
And that's the value of the words, basically.
Yes. Okay, so I think we have a roadmap. Haha.
Yeah, Magetta is going to be very sad that he missed out on easy parsing because apparently he hates parsing, right?
um, is hash. We hate parsing not because of like it has a history. It's because in silverware, parsing was kind of like the bottleneck of the process. When we're doing parsing in Okemon, it was like, oh man, this is kind of like very, very, very more convenient using parser generators, but it's kind of ugly. Uh, then we also made the parser community library for LFA. Do you know what's LFA?
Least
LF.
flavored Erlang.
Yes. So we made a library for this language from scratch, actually. So if you go to one of the repos and you search for knife, so here it is, the entire Farsi community library. This was very fun to make. I gotta say, like I did basically I was the driver almost all the time,
I see.
but it was so nice to like to reuse your parsers and stuff like that. Like, oh, the identifier is basically just right with something else and in a sequence, invalid chars and blah and blah and blah and stuff like that. That was very nice. This was very fun. And then we imported this parser community library in the other program, in the Spoon one. So if you go to source and you go to this, I think. Um, yeah, here,
By,
parse
by the way, Erlang is simply edited.
is what?
Erlang is simply edited.
Simply arithmetic. Yes, it is. We made an evaluator, very simple stuff. And the program that we managed to do, the advanced one, so it knows how to do this.
Oh,
So this is basically a
I
function
see.
application. That's it.
I see.
So yeah, so we made that work, and it worked. And but this traumatized Mageta in terms of parsing. But that's okay.
And it traumatized Nata in terms of Erlang, right?
Yeah, so some people didn't like the airline. Is starting with this line is starting with, and then we're gonna also put like a char and put like a, I don't know, special. And then this is gonna be is line starting with and then line and then hashtag. That's it. And this is gonna be return is line starting with line. Oops. Column. Cool. Cool, cool, cool. So now we gotta discover how to do that. So let's go to here. How do we know? I have a question. How do we know what is the type of each one of the elements of the NS array?
I don't think that you do actually. It's an array of references, probably.
So it's a bunch of IDs.
I think so, yeah.
Okay. So NS array Objective C. I know there is a Geek for Geeks page on this. Yes. Thank you very much. So here it is. Here it freaking is. I want to know how to do a loop over them. Can you help me, please, sir? You're not gonna help me, right? Oh, another thing that I just remembered. Using this type of parsing, we are gonna forbid the user to do stuff like this, right?
Indeed, we are. We are. We would need something a little bit more elaborate to deal with that. This is an assembler, not an actual language. Like, it's meant
Not
to
quite.
map
In
one,
assembly, our it's gonna be too incomplete, so it's kind of a language.
but
But
assemblies are too incomplete if
exactly.
the
So
underlying machine
somebody may
is
want
too
to use it,
incomplete.
man. Somebody may want to use that, and we are forbidding
That's the
them to
point.
of having conveniences.
No, but that's the point. This is an assembly syntax. Like, the idea is to have a straightforward mapping to what the program will look like when it's assembled. If And
Yeah,
the
I
convention is
understand.
that each line corresponds to a word, essentially.
Okay, so
Uh, we
how
like
do we iterate?
we can have some nicer syntax, but we would need something more elaborate than what we're doing.
Yeah, we're gonna have to have something more elaborate. That's true, that's true, that's true. Oh, here. Oh, you're using an enumerator. Okay. Okay, my Geta will love this.
Why?
Finding a, well, because it's kind of like, oh man, like why? And I'm gonna say, you picked it, we're gonna use it. Um, this is wrong. That's not the place. This is the place. We already have our array. So let's pick the enumerator for the program. So this is an idea of an element. So actually a line, right? And then while
Yes.
line enumerator of I'm gonna put more like program enumerator program enumerator next object. So what is next object? Oh, that's just a method of the enumerator. Okay. Then if if is label line,
Line.
and then we're gonna pass the line ID there. If it is, we're gonna do something different than if it isn't. So
If
the
it isn't, we can just do
we also
nothing.
need, yeah, we can do nothing there, but we also need to start in a map table. So let me do that real quick. So this is how you do it. Thank you very much. So I'm gonna just do
Labels.
ns map table star
Point.
labels. This is what we're gonna return here. Labels. Really nice, really nice. Then if you are okay, if you are, we're gonna have to do something more interesting, right? We're gonna have to parse it a little bit further.
Just a little bit. We skipped the first we've skipped the first character because we know it's a colon.
Yes.
Then we read
So I
until
think
we
I
hit a
want to
white
use
space.
this actually. I kind of want to use this. So let's actually pick this.
I wonder if there's a read to character or something like that.
You can search it. So this is gonna be okay. So this is kind of wrong. Yeah, this is kind of wrong. Oh, so this is not the ID. This is the actual object. This is not an ID. Oh, it is an ID. It is an ID to a specific object. So how does that work? Can I just do line ID here and it's gonna understand?
You
That would
probably
be
have
kind of
to
crazy.
cast it. You may need to cast it to a string, but maybe not. Just try that like that.
Okay, then
If we get
after
a
we do
type,
that, we're gonna grab the first. We're gonna grab the first uh, Geek for geeks, geek for geeks. Here, object at index. Thank you. So then we're gonna grab label, label column, and then we're gonna do line, object at index 0, and we actually want this to be a string. But how the freak we're gonna do that? There isn't a string value, I believe. I really don't think there is quite a thing, because there is that for integers, right? There is that for integers. We
Yeah.
discovered that by accident, but there is. So integer value, yes. So search if there isn't a string value, please. That would be very, very useful. Thank you very much. Then after that, then after that,
There isn't.
there isn't. That's quite sad. That is quite sad. How do we remove, how do we pop like the first changing case, dividing? Okay, so that's kind of weird. Okay, so that's what we want actually. So we want ns string label, and that's going to be something like label column substring 1. Then then we need to go back to the VM, and we need to do this there, and then we're gonna put labels. The object that we're gonna see. Oh, we need a counter as well. I don't remember. NUS? No. It is this. So this is gonna be like a counter, and every single time. I don't know if this is gonna work. Let's try counter plus plus. We're gonna do counter, and for the key, label. That should be it. Hello, Marin?
I think, let's see, separates by white space, label column, objects at index should probably be 0 actually, right?
What? Where? Here?
Yeah, right there. I'm pretty sure Objective-C is 0 based, right?
Yes. Oh no, yes, this is 0. This is 0. I was confused. This is 0. Then you create the label using substring to drop the column. Then you basically add that to the map. Again, I have no idea if this is going to work at all. And then there's an else if here. There's an else if, which is this. Which reminds me that this is probably kind of wrong.
We have to check actually.
Actually, we need to check inside. So this isn't an else if. We need to check if the label is already there.
Yeah,
So their label,
I think we
instead
don't
of
need the at.
self-register, it's labels.
I think we don't need the at around the label because the label is already an NS string. It's not a literal.
Oh, really? You think so?
I do think so.
So there, there, there. If you do, if you are, we're gonna throw an exception in your face.
We can return new instead. That's an option.
Eh, I'm gonna throw an exception. Uh, okay, so that's kind of not what I wanted, but okay. So this is gonna be label collision. Um, it would be nice. We're not gonna do it, but it would be nice just for whoever is crazy enough to watch until this time. We know it would be better to have some sort of location, and we're gonna tell you where it is wrong.
but but we do have the
We
location.
only have the location of the first one. Well, we
We
can
have the
do a
location of
lookup and find the location of the
no,
first one, but well,
and the location of the second one is the counter.
yes,
We
I
have
know.
both locations.
Um found um, found label um,
Collision.
percent this more than once lines. Um, okay, for now this is enough. I really don't know how we can make a string out of that.
Um,
Like, can we put parentheses and just make a string? Like, is that an option? Like, can we do
maybe. I
this?
don't know. I don't know.
Label. Uh, fuck. Okay, we need to also do
We have
this
to do
there, but instead of doing whatever this is, uh,
labels.
we're gonna do labels. Yes, we're gonna do label. Convert that to an integer. Thank you very
We
much.
don't need the at sign in front of the label.
We don't need the at sign. Are you sure?
I am.
I don't know if I'm
I'm
sure.
sufficiently sure that I'm suggesting you do it.
Okay. And theoretically speaking, this is doing all of that. This is doing all of that.
Indent the returns labels, please.
Where? Oh,
Line
here.
53 is not indented.
I'm gonna give a -1 chance of this working. Minus
Minus.
110%. A hundred
Okay.
percent.
Oh, we actually need to implement a function up there, don't we? I'm pretty sure the
Oh yes, we did. Yes, and I got a better name. Uh, okay. So this is definitely an if. Actually, not even an if. Um, ns string objective c. Okay, okay. So let's see. Method and purpose. Has prefix returns a boolean and indicates whether a given string matches the beginning characters of the receiver. Isn't this exactly it?
yeah, that's what we want, I think.
Okay, so this is basically gonna be so, but we need to cast the ID to a string.
And we need to
How
cast
in the
also
fuck we're gonna do that?
the target is a character. It should be a string as well for this to work.
No, but this is very easy to do. So just change this to an s string pointer
Pointer.
target, and this
And the
guy
line,
we just change this to this, and we put that in there.
yeah. And the line, um, I think we can just say the line is an NS string pointer, I guess.
I don't know if that's gonna work.
You missed the
Line
T. You missed the T.
line has prefix target. Is that it?
It should be.
I don't know if
I
I don't
think
know why you're so confident. I'm not confident at all. Oh
let's try it.
balls.
The worst thing that can
Uh,
possibly happen is it breaks.
ns map table test pass1 program. This is already a pointer, so we don't need to do anything about that. Whew, okay, how the heck do we print that? So let's go to... Oh, it's terrible. Okay, it is in
Uh,
fact terrible.
by the way, I'm going to have to leave soon. Not quite yet, but soon.
Labels. Okay. Um, Labels. Compilation errors time. Implicit declaration, that makes sense. Uh, Parser, boom. So sad that you gotta leave. We are getting somewhere, and then you have to leave. But oh well, part of life. We should actually change this to NS strings as well. There. Are you there, Marin?
I'm still here.
Cool. I'm gonna change the signatures of these two. I really don't know if this is gonna work, but well. There. Okay, next year. Thank you very much. Expected. Okay, so maybe we can't use question
It doesn't like
marks.
the question mark, apparently.
It allows file names with plus, but it doesn't allow question marks.
File names with plus is part of the file system semantics, right?
Yes, I believe so. Yes. So let's also remove from there. Next error, please, compiler. Okay, a bunch. Expression result unused. What? Oh, I didn't remove from the callers. Okay. Next error, please, compiler. Interface type cannot be statically allocated. Probably, but that's
Oh, it needs
because
to be
that's a
an NS.
pointer.
It needs to be a pointer, yeah.
Everybody are pointers. Next error, compiler, please. Instance method substring not found. That's a problem. That is a fracking problem. Sir, where is the substring thing?
I wonder if you need to capitalize the string in the substring.
Oh, you think that's possible?
It might be. I mean, it's freaking camel case.
I don't know if I believe you. Oh, substring from index. Which documentation should I trust? Random internet shit or Apple? Because apparently Apple is garbage. Are you garbage as well, internet? Yes, it is garbage. Implicit declaration of find in a numerator is invalid in C99. I have no idea what you mean, bro. So let's go to VM instructions. Yes. Find in a numerator is our function. This is not their function. Okay. I understand that. I understand. So let's go here. Let's add a new header, which I'm gonna put import here. Okay, next here, please. Unexpected at.
At
So
label. You don't need the at there, actually. Because label is already a pointer.
that's true. That's true. Okay.
GS
Oh,
tiny
string value
string
doesn't
does not.
exist. String value doesn't exist.
It doesn't.
It doesn't really exist. Okay, so
I warned you
how
about the
to
ferret.
format string Objective-C? Formatting string objects. Should I trust Apple? Every time I do this, I'm not a fan. I'm really
And
not
a
a fan. Oh,
string.
string with format. Okay, so you can do it. Okay, that fulfills our needs. That fulfills our needs.
Okay.
So here I'm gonna put all of that. In there I'm gonna replace with this, and in here, oops,
Whoops.
I'm gonna put.
Label. You're missing the label. You deleted it for some reason.
I'm deleting the label. Oh
Yeah,
yes.
there's three arguments. The first one is the label.
Okay. Still kinda mad. So format specifies type ID, but the argument has type NS integer. NS integer. AKA long. Okay, so thank you for the advice. Thank you for the advice. So this is n percentage %L. Next. Invalid conversion specifier. I am confused. This is not how you do long in C?
LU, I guess.
LU, I think it's unsigned. No, you are right. Non-void function does not return. Line 66. 66, 66. Oh, okay. So you are a pointer, I'm returning null. Okay. So now we
Yes,
just need
tiny
to
string is
understand
filled.
the string value thing. We just need to understand that and we are done for today. Come on. Come
Uh,
on.
I I think you can just remove the string value and just have line objects at index 0. It worked. It actually worked.
Okay, okay. Now, but there's another gotcha here. So we're gonna use equality.
Line 0 and 5. What do you mean 0 and 5?
Found label equal. Okay, we should definitely put some stuff. Back this, back this. Thank you very much.
What do you
Um,
mean 0 and 5?
Label collision, uncaught exception. Reason, found label equal more than once. Late lines 0 and 5. Okay, so we should definitely take a look on the program. So do we have?
Line 0 is main, line 5 is equal. What are you talking about?
That's a very good question. That's a very, very, very good question. Okay, I have an idea, which it is printing the label. So let's see, what are you printing? So there, uh, there. I think I'm understanding more Objective C with this session, just with the whole pointers thing. Label, main and equal. So it is trying
What
to
gives?
find.
What gives, man?
That's really weird. That's really, really weird. So I have an idea. Let's pick these and put it immediately after. Okay, thank you very much. Main. Then it printed that there isn't anything because we didn't add it yet. That makes sense. Then when it found equal, which is correct, that doesn't have the column, it is correct. I didn't count. It is line 5.
It
One,
is.
2, 3, 4. We are not counting these, right?
We are.
We are. Are you sure? Yes, we are. Okay, so my only thing is that this is not working, which
It
is
said that line 0 is the one that has the collision. Line 0 is the main line.
yeah, line 0 is the main. That doesn't make sense. That doesn't make sense.
Yeah.
Unless unless nothing. This doesn't make sense at all because equal is here and this thing needs to be this, and we are grabbing this label is not, no, we just printed it needs to be equal, and then we are converting that to an integer value, and the count is at 5. Is this function find something something correct? I'm starting to doubt that this function is correct. Is equal to string found equals true, break found return found. That's quite a thing. Wait, is this how is this doing things? Key. This is supposed to be target, and this is supposed to be target as well.
Wow. Wow.
Dumb,
We found a bug.
a bunch of idiots. And why? And why? Because we don't have a program to test our crap. We don't have, because if we did, this would be have been discovered in all of these. Huh?
Ah, yeah. That's kind of sad.
Oh boy.
But now it works apparently. Now that they fixed the bug.
Does it? I have no idea actually. So main true equal 095. 0, 2, 3, 4, 5. No, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ta-da! It works, my friend. It freaking works. Now, do you have to go?
I have to go,
I'm so sad.
unfortunately. We did make some good progress though.
We
And we
did
found
make,
some bugs.
yes. And we found some, and we made error messages, which is quite rare. That is very quite rare. We made error messages, useful error messages. This is very useful. Of
It
course,
is.
I would like to like not have to have some colors like red. That would be nice. And I do know how to do that because I did in silverware. Uh, but this is very useful. This was not unproductive. Like it took some time for us to discover how to do the crap. There's actually a test that we are not doing, and we should do that. So let's
Oh,
put
what?
something. Yes, thank you very much.
Uh, it's
Thank
so
you very
great
much.
when things work.
It's so great when things work. Yes. We are doing great. So now we can go back to sum. And after, okay, so let's just do a recap of everything we did. So we did parsing, like reading the file, doing some stuff with it.
The
Uh,
first pass is done basically.
the first pass is basically done. The first pass is basically done. And the past one basically goes. It's gonna be very inefficient, of course, because it's a two-pass parser. But who
But it
cares?
has
In
it
Magetta, in
has to
full
be a
Magetta style, who cares?
two-pass parser unless we want to deal with.
Yes, unless we want to deal with what parsers do, like commercial parsers handle, right? With lookaheads and stuff like that. I think Marinho lost internet again. Anyway, so we are parsing once using just saving the labels, just saving the labels, and then parse pass two is gonna be when
Oh, my internet just
yes,
sneezed
yes,
again.
yeah, I noticed that. And I was just explaining to the video that the pass two is gonna be doing exactly the same thing, but saving the lines, using the map table that we just used. Actually, I'm gonna do that right now. So this is gonna be the result. Yes, NS mutable array. So this is gonna be result of pass two, passing labels and the program, and that's gonna be it. We're gonna do what is written here.
Yeah, real quick, just about the two pass thing. It's either we do two passes or we have to accept that labels have to be declared before they are used, which we may not want.
I think we can do look aheads anyway. Like what? There are some compilers that do that, right? Like single pass
Ah, that's
compilers.
that's I'd rather not.
No, I'm not saying we're gonna do that, but we could do that. We could. We are aware of this option.
That strikes me as actually less efficient than just doing two passes.
I
Because
think
if
it depends on the program.
it depends on the program, but if there's like 50 references to something that's defined at the end of the file,
Yeah, but that's
it's
kind of
gonna
like a
suck.
worst case scenario that you're proposing there.
Yeah.
Because we are good boys, we have this, and then untracked files. Okay, I don't want to have you. K as well on you. K on you. Unstaged changes. So this is wrong. Okay, I'm glad I found that. This is changing to this, and this is changing. I actually don't want to change that.
Man, I'm having internet problems, like a lot.
Yeah, that's quite
Actually,
sad.
it's not even internet problems. It's my router that's acting up.
I understand. I understand. What is wrong about this?
Right.
I think it's the formatter.
There's probably some trailing white space that it removed or something.
Yeah, so let's add this, and this. Why not? Let's do a commit. Add parser. Add parser. That's really descriptive. Uh, then we're gonna do all of these. So update main function to use parser, and then add some example for testing parser, and I'm gonna commit that. And there should be already a branch. I'm not gonna check out that. I'm gonna make the PR right now, but we did stuff. Oh,
It is
look at
stuff.
how the formatter formatted this, man.
Oh, it turned it into a one-liner. Okay.
Yeah, I'm so glad we have a formatter. Like it sounds legit that we're not just joking.
Yeah.
Okay, so
It's
I'm gonna finish
it's
the
very
recording.